So the equation was fx.
So no, you just got to practice on reading it properly. So f of x, because remember that's a shorthand for a story. The story is I'm going to do a function based on the variable of x, and instead of saying all that, we just say f of x.
Okay, f of x equals x parentheses x minus 2 parentheses and another parentheses x minus 4 parentheses squared.
Okay.
Now see, I know what's the real zeros because what's within the parentheses. You just had to make it to the opposite, and which I'm still stuck in with the.
Okay. So yeah, you lost me the moment you went into rules, and I know you knew that because you all of a sudden started to stutter.
Yeah.
You're like, uh-oh, I just told him a rule. He's going to call me out for it. So here's the way that we want to kind of look at this one. This is actually one of my favorite topics because it shows you how powerful we are if we think about it as mathematicians versus if we think about it as computers and rule doers. Because this thing that I'm about to show you works with what you have up here. It also works with, we could have something that the calculator really can't handle. Like if you go into GeoGebra or your graphing calculator or whatever, and you type in to the 300th power times x minus 4 to the 800th power, you're actually going to get something very similar to what we're about to graph, but your calculator can't handle it. So you actually have the power, after we kind of talk through it, to do exactly what we're about to do for this really big problem. But we're going to use the smaller problem because it's less intimidating. Okay.
Okay.
But this is a place where if you understand the logic why, you get to see a beautiful story and you can actually outperform the calculator really, really solidly. So if I wanted to graph this thing, the first question that a mathematician could ask is, instead of trying to tackle the entire thing at once, let's just find some easy points to start with. Is that fair? Okay, what's an easy number, especially when you're talking about multiplication, which we have going on here? The number 0 is a very easy one to multiply to.
Well, the thing is, you just wanted to. How am I gonna explain it? I just know it, but I can't explain it. Hold up.
Okay, how do you multiply to 0? Like, how do I take 2? What do I multiply it by to get 0?
You just like plug it into x.
So, like, here's my question. If I had 3 times something equals 0, what's the something?
But it's gonna be 0 because.
It has to be 0.
Yeah.
Because that 0 times things gets 0, right?
Yeah.
That's what we call the zero product property. It's a fancy sounding word for just realizing that if I want to get 0, I need to multiply by 0, right? If that's true, then the logic goes, okay, look at everything we have here. This is being multiplied, this is being multiplied, this is being multiplied. True or false? If any of those were 0, everything is 0.
Yeah. Oh, I see.
So what you do is you say, if 0 is such an easy number, then let's just start with this. The first thing could be a 0 and make this true. The second thing could be a 0 and make this thing true. The third thing could be a 0 and make this thing true. Which means that, like, when does this second line become 0? What does x have to be?
X has to be x equal positive 2.
Good, which you can get at from just adding 2 to both sides if you want, or telling it to you as a story. So you got x equals 2. What about the next one?
The other one, you have to square root it.
Okay, so that'd be x minus 4 plus or minus square root. Remember, the only way you get rid of a square is with a plus or minus square root, right?
Yeah.
But plus or minus square root of 0 is still just 0.
Yes. And then it will be, you have to add 4 to both sides.
Very nice. So x equals 4 makes the second part 0, which makes the whole thing 0. So there you have it. Those are your zeros. In your graph, if you wanted to graph it and make easy points, x equals 0 is a 0, so we'll put that at a height of 0. X equals 2 is a 0, so we'll go 2 over and put that at a height of 0. X equals 4 is a 0, so we'll go over to 4 and put that at a height of 0. Those are already points that have gotten your picture started.
Okay.
Okay?
Yeah.
Now, from here, the rest is kind of a little, like, it happens from exploration. So I did this in the lecture, but from now on you don't have to if you remember the rule. But the exploration goes, now maybe we check some points between. Maybe we check some values in between each of these zeros and we say, how are those behaving? And we say, okay, well, let's take a look. For example, like if I wanted to look at numbers that are way over here, big positive, you tell me what happens, Bianca, if I throw in a number like 500 for x. What are we going to get?
Wait, hold up. Can you repeat that question again?
Sure. So my question is, let's look at some numbers like what happens if I put in 500? Big 500 number, okay?
Okay.
We're just playing around. Like this is something that we do before the test so we get an understanding of the rules, but then afterwards we don't have to do this anymore. I'll show you what you need to do on the test in a moment. So we'll do 500 minus 2, and then we'll do 500 minus 4 squared. So real loosely, 500, big number, right?
Yeah.
Times this thing, big positive number, right?
Yeah.
This thing here is what?
Positive too.
A big positive number, right?
Yeah.
So all of this together is a big positive number. Like that's good enough for my sketch. That just means as I go over to the right, I'm going to get big. Cool. From here, we can say, okay, that's going to be what has to happen. And then eventually we come down and we get to this 0. So there we go. We've got a little bit of our picture going on so far. Now I say,
Oh
okay,
my gosh. Wait, hold up. My brain, hold up. I'm like shocked. Hold up. Because I'm like, oh wow, now I understand this now. Hold up. Oh wow. Okay. Now I see.
okay, cool. So now let's look at like this. I got to the 0 at 4. We need to go in between 4 and 2 for our next exploration. We could do f of 3, for example. What happens if you plug in 3? That'd be 3 and 3 minus 2 and 3 minus 4 squared, right?
Yeah.
So let's see, 3 positive number. This gets us what?
Positive.
Positive number. This gets us
Another positive.
another positive, right?
Yeah.
In fact, if you recognize, this is the only thing that really changed in our story. Because in the one above it, you had positive, positive, positive. Here you have positive, positive, would have been negative, but made squared is still positive, right?
Yeah.
So the only thing that changed is that on the inside it wanted to be negative, the squared made it positive, right? That's
Yeah.
where we get the quote unquote rule that says that sure enough, over here I have to be positive. So like the graph is going to have to go where I go back towards the positive, and eventually I'll come down and get back to this other 0. Why did that happen? Because the squared, the even power, made it have to be positive. So this is where we can pull out a rule, an observation as mathematicians, and say that at even powers, at even multiplicities for our zeros, you're always going to get this effect where it wants to change to the other sign, but it's prevented by the even power.
Oh, I
So
see.
that's why, and you can now, we can, in the future, we'll just look at this much more simply and say even powered exponents are going to be times when I touch the 0 and then I come back because I can't cross, the even power doesn't let me.
If I like screenshot this.
Sure, but wait for a little bit more because we're going to keep going, okay?
Oh, okay.
So now let's look at the next exploration. So now we're looking, we got to 3, or I got to 2, that's a 0. Now let's look at another exploration point like f of 1. What happens when we type in f of 1?
It'll be 1 parentheses 1 minus 2 parentheses 1 minus 4 parentheses squared.
Good. So let's look at this one. We've got a positive number. We've got a new negative thing. And this stayed wanting to be negative, still positive though. So we've now
Yeah.
switched from positive, positive, positive to positive, negative, positive, which means this whole thing is just negative now, right?
Yeah.
But as a story, it means that when I crossed that 0, I made the middle 0 thingy negative, and I wasn't in any way interrupted by an exponent. So sure enough, we're going to go negative here. And then I'm going to come back up eventually and have to touch that 0.
Okay.
Now let's do the last one, and I want you to walk me through the logic of it. So we need to go with a number that is before 0. What number do you want to try?
-1.
-1. I love easy numbers. So let's try plugging that in. What do we get?
-1 parentheses -1 minus 2 parentheses parentheses -1 minus 4 parentheses squared.
Okay, so now let's walk through and look at the signs. This one is
Negative, and
Yeah,
Another
that's a
negative.
new negative. So we've introduced one more negative into the story. This is a negative, right?
Yeah.
And this is a
Positive.
positive. So you got negative times positive gets us what?
Still negative.
No, negative times negative gets us.
Oh, positive. Oh my goodness.
This thing gets us a positive.
Positive.
Because notice you can actually look at this as being to the exponent of what?
Because, oh my goodness.
That's to the exponent of 1, right?
Yeah.
So again, when it wanted to change its sign, there was nothing preventing it. And when we changed this negative, it ended up canceling with the other negative before, and we're back into the positive realm.
Mm-hmm. Oh,
So
I see it now.
really, really beautiful story when we take time to understand it. But it's even cooler in the fact that we actually get to experience math, like as a mathematician, what we can actually do moving forward. You ready to see how you can solve this problem in no time flat? Here's how I would solve this problem if it was given to me. Now that we've done that exploration with our homework and with the lecture and everything, I'm just going to section off a small little space here, and I'm going to imagine that this is all the work I was about to do to answer the test, okay?
Yeah.
Okay, so we've got zeros. We'll do this little bit of scratch work off to the side, and we'll say I have zeros at the 0, the 2, and the 4, right?
Yeah.
I'll plug in a big number in my head that says if I go really positive, I go really positive. So I go up this way, right?
Yeah.
That's all you have to do in terms of calculation. The rest is just story. You can look at the exponents and go, well, the first 0 has an even exponent, so I'm not going to change my sign. The next one I have an odd exponent I must have to cross. The next one has an odd exponent I must have to cross, and you're done. So you actually can complete this entire problem by doing, so you're given this, you can do this work right here, this one if you want to, otherwise you can kind of just logic through it, and then this and you're done. Like this is a 4-step problem that takes maybe 3 minutes if you know what you're playing with and why.
Okay.
Because yeah, you're literally just going to be like, I see the zeros. I know that when I get big, I must be positive because I tried it. And so everything else must cross when the exponent allows or bounce off when the exponent prevents.
Okay. That's actually cool though.
Isn't that really cool? Like you can, and so this is where I was kind of saying, you can take a screenshot here now, and now I want to show you something really cool, okay?
Okay. Okay. I got it.
You got it?
Yeah.
Okay, so here's the reason why I said, so now let's do something that even like the computer, if you throw this into GeoGebra or an online calculator, it will struggle really hard. So let's do something like, I don't know, let's do x minus 3 to the 400th power times x plus 2 to the 199th power times x to the 301st power times x plus 4 to the third power. Like if I gave you something like this, it's actually just as easy as the problem you did. Where are the zeros going to be? The zeros are going to be at x equals 3, -2, 0, and -4, with their multiplicities being even, odd, odd, and odd. So I can actually graph this entire thing right away by saying, where are my zeros? They're at 3, 0, -2, -4. In my head, I can say, what happens if I plug in a big positive number? I'm probably going to get something that's a big positive number, and we'll just go through the zeros. The even one causes me to bounce. All the other ones are odd, so I'm allowed to switch over, and we're done.
I see. That's. Oh, I see it now. Because.
Like you can do this thing lickety split, and this will like I said, try it in GeoGebra. It will crash the computer. I've tried.
But from this equation, would it be a polynomial or is
This
it?
would be a polynomial, yes. The
Oh,
reason
okay.
you can see that is because imagine doing all of the foiling that would go along with this. Like there'd be a lot, right?
Yeah.
Like a ridiculous ton. But at the end, you would have nothing more than x's times numbers and stuff, right?
Yeah.
So for that reason, you would never get a fractional exponent. You would never get a negative exponent. You would never have x's appear on the denominator. You would never have square roots magically pop up. So this is a polynomial. It's just a very, very high degree one. And in fact, you could actually calculate what the degree is pretty easily. Because if you FOILed all this out, if you factored all this, if you distribute all this out, this one would eventually have x times itself 400 times. This would have x times itself 199 times. This would have x times itself 301 times. This would have x times itself 3 times. And when you combine all of that together, you would get x to the 400 combined with 199, combined with 301, combined with 3, and whatever this number comes out to be would be your leading power. It'd be the biggest you could possibly get when you multiplied all the right stuff.
Okay, I see it.
So it's like exponent rules, but like abstracted.
Okay.
So yeah, this is exactly how mathematics works. Is it's not about calculators because calculators hold us back.